It's on now.
What? Can I teach the class then?
No. All right, here we go. So our first question, I know they have an f at x, but I'm going to use y. Y equals 2x squared plus 4x minus 6. I'm going to switch that to just regular pen. Okay? All right. This is not set up in vertex form, yes? This is set up in the form where we have to use the negative b over 2a. We have to recognize our a values here, our b values here, and our c values here. So I'm going to get negative 4 over 2 times 2, which is negative 4 over 4, which is going to give me a negative 1. So my axis of symmetry is x equals negative 1. And I have the x component of my vertex. How do I find the y component of my vertex?
Plug it in.
Yeah, plug it in. So I'm going to take that negative 1, I'm going to plug it in right here, and I'm going to plug it in right here. So what negative 1 squared is 1. 1 times 2 is 2, plus 4 times negative 1 is negative 4, minus 6. So negative 4 and negative 6 is negative 10. Negative 10 added to 2 is negative 8. So my vertex is at negative 1, negative 8. 8. Down there. Okay? I know my axis of symmetry is. We got that? Now, can I pattern graph off this using 1, 3, 5? No, it's not 1, 3, 5. It's what? It's 2, 6, 10. Agreed? Because there's a lead coefficient, right? A value is at 2. So from here, I'm going to go right one up 2, left one up 2. Hey, that looks important because it crosses the y-axis. Okay? And then I'm going to go right one up 6. And left one up 6. Hey, what is this? Here and here.
Roots?
Those are my roots. They cross the x-axis. Great. All right, so here's my parabola. Okay, so let's answer some of the questions. The vertex is that. The axis of symmetry is that. My roots are, that's a root, so that's at 1, 0. And here's my other root, which is at negative 1, negative 3, 0. Is that all right so far? The y-intercept is 0, negative 6. And so if I fill out the table on this problem, I usually put right in the middle my vertex. So I got 0, and I got negative 2. So at 0, I got negative 6. At negative 2, I get negative 6. Hey, how did I find those real quick? I just went to my grid. And then this goes to 1, this goes to negative 3, and those are both zeros and zeros. Okay? I filled out the table without plugging my information back into the problem. I put my vertex right in the middle of it, and then because of my pattern graphing, I was able to find where it crosses those points. That's a 6-point problem. Okay? Got it? All right, let's move down the page. Next problem. We have, I know they use f at x, but I'm going to use y. X squared minus 2x plus 1. Okay? So I'd probably say let's use the negative b over 2a. So that's negative 2 over 2 times 1. The reason I know that is because my a value is 1, my b value is that, my c value is that. So negative 2 is 2, 2 over 2, 2 over 2 is equal to 1. So that's the x component of my vertex. So I know my axis of symmetry has to be x equals 1. What do I do with that 1 in order to get the y component of my vertex?
Plug it in.
All right, 1 squared, 1. Negative 2 times 1, negative 2, plus 1. So that gives me 0. So 1 comma 0. Oh, it's a root as well.
Root dogs.
Okay, can I graph using 1, 3, 5? Yep. So right one up 1, left one up 1. Hey, look what I found. Right one up 3, left one up 3. There's my parabola. All right, let's answer the questions. They wanted the y-intercept. That's the y-intercept right there. So it's a point, so listed as a point, 0, 1. And then my axis of symmetry, the axis of symmetry we found right there. Cool. That is a 3-point problem. May I move forward? We all okay? All right, so that was problem number 6. Let's go to problem 7. Okay, problem number 7. We have y equals negative x squared. Oh, it's opening down. Plus 6x minus 8. So I think I'm going to have to use my negative b over 2a. So I get negative 6 over 2 times negative 1, which gives me negative 6 over negative 2, which gives me positive 3. So I get 3 comma something. That means my axis of symmetry is this. According to our singer in the back, we're going to plug it in. All right, so I'm going to plug. If I plug 3 into x, I get 3 squared, which is 9. The negative comes along, so I get negative 9. Plus 6 times 3, which is 18, minus 8. So negative 9 and negative 8 added together is negative 17. 18 minus 17 is 1. So I get 3 comma 1. Okay? Does it open up or down?
Down.
Pattern graph work, how, which way?
1, 3, 5.
No.
2, 6.
No.
Wait.
Negative 1, negative 3, negative 5.
Thank you.
Good work, Jacob.
No applause, just throw money.
Yeah.
All right, so right one down 1, left one down 1. Right one down 1, 2, 3, 4, 5, down 3, 1, 2, 3, excuse me. Left one down 3. I guess I could go right one down 5. 3, 4, 5, and down 5. Okay, we found that. Cool. Let's see what this one's asking for. This is number 7. They want the vertex. Well, there's my vertex. And they want the roots. Okay. Well, that's a root right there, which is 4 comma 0. That's a root. And that's a root right there, which is 2 comma 0. And the problem's done. A-okay? Life is good? Problem number 8. Can I move on? That last one was a 4-point problem. Jackson's back in the house. Oh, here, Jackson, here's your homework that you didn't put on your desk. We put that on Seth's desk. All right. Eventually. See how far we get. What number am I on? I'm sorry.
7. You were no 8.
8.
Ocho.
8. Here we go. Number 8. So I get y is equal to negative 2x squared plus 8. Hey, what value is 0? A, B, or C?
Wait, C. Wait, no.
What value is 0? B. So if I use negative b over 2a, and b happens to be 0,
0.
so part of my vertex has to be 0. Okay? That means my axis of symmetry also has to be the line x equals 0. Okay? So if I plug this in, 0 squared is 0, negative 2 times 0, 0, 0 added 8, 8. Pattern graph work? What's it going to be? Nope. There you go. Negative 2, negative 6, negative 10, because that's a negative 2. Okay, we got to double it and make it negative. So I'm going to go right one down 2, left one down 2, right one down 6. Oh, look what I found. Root. Root. Okay. All right. Let's see what it's asked for. Hey, they wanted a root, so I've got a root right there, which is 2 comma 0. Got a root right there, which is negative 2 comma 0. Those are those. And then the y-intercept, oh, that's all. Hey, that's the vertex as well. So the y-intercept is 0 comma 8, which also happens to be the vertex. That's it. 4 points for that problem. You're marking down what you need. This is a good study guide for next time.
When is our next test?
Friday.
Where test is Friday?
Quiz Friday.
Quiz Friday. Okay. And that's wait, this Friday? We've been learning?
So, this as well as what we've been learning. What?
This Friday.
This coming Friday.
And then when do we have a test? I thought you said
The 20th is our test.
How long is the quiz?
Regardless of there being a walkout supposedly planned that day or not. There's still a test that day.
Oh, yeah.
How long is the test, quiz?
I believe it's just a front and back.
Okay.
Because the compound shooting.
All right. Here we go. Number 9. I'm on the back side.
We are too.
All right. Y equals x squared minus 4x plus 3. So I have to use negative b over 2a. And I know that so I get negative 4 because my b value is negative 4. 2 times a, well, my a value is 1. So I'm going to get positive 4 over 2, which comes out to 2. So 2 comma something is my vertex. So x equals 2 is my axis of symmetry. We are plugging in that 2 right there. So 2 squared, I get 4. Plugging it in there, I get negative 8 plus 3. 4 added to 3 is 7. 7 minus 8 is negative 1. So I get 2, negative 1 right there. Pattern graphing work?
Yes.
So 1, 3, 5 or no?
Yes.
It is. Good. So it is 1, 3, 5. And let's do it. So I'm going to go right 1 up 1, left 1 up 1. Hey, I found roots and a root. Right 1 up 3, left 1 up 3. Found 8. Where crosses the y-axis? All right, what is it going to ask me for on number 9? It asks for the roots. So that's a root. So that's 3 comma 0. That's a root. That's 1 comma 0. The axis of symmetry. Oh, we have that right here. Hey, okay? Good. Number 10. Number 10. This one's going to be set up for us to use negative b over 2a for find the vertex and the axis of symmetry. So my b value is negative. My a value is 1. So I get 2 over 2, which is equal to 1. So 1 comma something is going to be my vertex. My axis of symmetry is x equals 1. Guys, quit. Brady's out of control. He's going to play with matches, run with scissors.
No, that's just Joe.
All right. So in order to find the y component of my vertex, I'm going to plug this 1 in here. So 1 squared is 1. Negative 2 times 1 is negative 2 plus 4. So 1 minus 2 is negative 1. Negative 1 plus 4 is 3. So I get 1 comma 3 right there. Does pattern graphing work on this one?
Yeah.
Yeah, it works as 1, 3, 5. So right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3. Roots does it good. So complex roots because it does not cross the x-axis. Love it. And then my axis of symmetry we found right there. That's a 3-point problem. Number 9 was a 4-point problem. Ism. Cool. Number 11, the extra credit. The extra credit was worth 4 whole points. So some of you earned 4 points by doing it. Some of you got partial credit on it, which is great. Okay, this one is set up This is set up to allow us to find the roots pretty easily. Agreed? So if I go x minus 2 equals 0, I get a root at 2 comma 0. If I go x plus 2 equals 0, I get another root at negative 2 comma 0. So 2 comma 0, negative 2 comma 0. Those are my roots. These are in factored form, so it sets it up nicely for us. How would I find the vertex? Well, the vertex is going to, and the axis of symmetry are halfway in between those two. So that means my vertex is going to fall at 0 comma something. So if I plug 0 in, I get 0 minus 2, which is negative 2. 0 plus 2, which is 2. So that's 0, negative 4. So there's your parabola. What's your vertex? That's my vertex. What's your roots? 2 comma 0, negative 2 comma 0. Yeah. And that's it. This is yours to keep. Hold on to it. Study from it. Learn from it. Those of you who took it today, I will get it back to you tomorrow so the video is up so you can take a look at it, okay? All right. We good? Everyone happy? All right. I'm going to do notes first and then see where we're at as far as going over the homework. Yeah, you need to come see me out.
I would have freaking tripped.
That ain't my fault you don't know how to walk.
Stand it up. All right. So I'll lecture first. We have time to get to the homework. Great. If not, we can also have yesterday's homework or today's homework due tomorrow. Yeah, so it's not too big of a deal. All right. So how do we know which method to use? We've seen multiple methods of these. Agreed? But they're all parabolas. So they all have pretty distinguished ways that we look at the graphing. The 1-3-5 pattern works really well, especially when you have the vertex. But so let's take a look. Let's move on a little bit. First page. Okay, so my thing doesn't work because my stuff is outdated for some reason. But I know you all have a dolphin, and I know that like here down in this region is all water, right? Where the x-axis is above the water line. So they want to know, using the parabola, answer the following question. So I'm going to label the vertex here. I'm going to label that vertex. Looks like 4 comma 4. I'm going to label the roots. That looks like 6 comma 0. And that looks like 2 comma 0. Agree?
Yeah.
All right. So for what intervals is it increasing? So increasing means that this is coming up.
Negative infinity.
Yeah, so if the ocean was negative infinity deep, it's going from negative infinity all the way up to the x component of my vertex, but it's a rounded bracket because we don't include right there, okay? Because right there at the vertex, it actually is not increasing or decreasing. It's actually a horizontal line, okay? So x equals 0, okay? We good so far? Thank you, thank you. I'll get these back to you tomorrow. I recorded the first part of the lecture, which we'll be going over these, so you can utilize that tomorrow, okay? But we just started the notes, which should be on your desk. So this is where the whole thing was increasing. So where is it decreasing? Well, it's when the dolphin's on his way back down. This is all decreasing. So where is it decreasing? 4 to infinity. 4 to negative infinity. Again, we're assuming that the ocean is infinitely deep, and I realize it isn't. But so if we say that loud enough, then you're going to get those people who think the world is flat. They're going to start saying it's infinitely deep. Okay. You think the world's flat too? Great. All right. For which values of x is the function positive. So what is it? If I'm asking for it's positive, what does that mean? It's above what? It's above the water, so it's above the x-axis. So this region here, this is where our function is positive. So using our information up there, where would you say our thing is positive using the x components? Where is that positive in the x direction? 2 to 6. Now here's a quick question. 2 to 6. Is this a point? No. This is set up as interval notation of where our graph's positive. So that just means, hey, our graph is positive above that. And then they want to know, when are we negative? So it's negative here, and it's negative here. Meaning, if I plug an x value in at either of those regions, my y value becomes negative. For letter C, if I plug any number in between there, decimals, fractions, or whatever, as long as it's between 2 and 6, my answer will be positive, which is pretty good to see. All right, so where is this negative? Negative infinity to 2. And then where is this negative? 6, negative infinity. There you go. Or 6 to infinity. Yeah, because we're going in the x direction. B. Where is it decreasing? Yes, it is. I'm sorry, I'm making errors left and right, and because you guys are so sharp, you're catching all my stuff. We doing all right?
Yeah.
We feel all right? The rest of the class, everyone's all right too?
Yeah.
All right. Okay, so again, I'm sorry my dolphin's not working, but hey, you guys can see it. All right, so the next slide, we're going to talk about this roller coaster. Agree? Again, my roller coaster's not working. I'm sorry. It's a cheap fair ride or something. Okay? So, but you're seeing the roller coaster coming down and then going, your picture of it going down. Okay, so where is this function increasing? Where is this increasing? Well, I'm going to label my vertex to be 3, 1. I guess I could label that as 0, 10. These are just points that I can see. But it's increasing from here to here. So where is it increasing? From where to where? 3 to infinity. Now this is a big roller coaster if we're going infinitely high or infinitely dropping, which is kind of fun. That'd be fun. I just want to get up. All right. Where is it decreasing? Well, this is all decreasing. So tell me where it's decreasing. So negative infinity, it's coming in the x direction from negative infinity, going all the way up to 3, and it's decreasing. Okay? Where is our function positive? That means where is it above the x-axis? Yeah, the entire ride. The entire ride is above the x-axis. So from negative to positive infinity. Sweet. And then what was, this is the y-intercept. So 0, 10 is where it crosses the y-intercept. Now they're saying that's where the roller coaster begins. It would have been nice to know that in the beginning, but everything there we look pretty good with. Happy? Making sense? Am I good on time? Good. Can I go to the next slide? So we have the table method, which I think is the cheapest method of these. I really do. It's not my favorite. It's not my favorite for a number of reasons. Because if you have to use the negative b over 2a, which is fine, and then you plug it in, you get another number. And I say, okay, fill out the table. So you have the vertex label in the middle as like 2, 6. And I'm like, okay, give me a number to the right of 2. And you're like, 471,312. Yeah, go ahead and plug that in there, mister. Okay? So the table method, for some reason, doesn't always make sense. It doesn't make sense because I don't know where your logical thinking's thinking going, Okay, I need to pick a number to the right and a number to the left, and you're picking some obscure numbers. Okay, the 1, 3, 5 rule I absolutely love. Obviously, this is influenced by our A value, but this pattern graph helps so much as long as you have the vertex. When you're factored, so if you have like this, when it's factored like that, that kind of presents it to you of where it's going to be crossing the x-axis. So it would cross the x-axis at -3, and it would cross the x-axis at 7. So it would create -3, 0, and 7, 0. And halfway in between those would be where the vertex and the axis of symmetry live. And then the vertex form, this is the one that we just learned, and I think this is a real favorite for most, where we have this, where our vertex is h comma k, and you have to remember, take a look at our signs. Okay, and then the pattern graphing works great. So those are all things that we have done. They work well. Sometimes it might present itself saying I should use -b over 2a and try and table method it. Sometimes it might even factor better. All right. So the very first problem. Not a big fan of the table method, so I try to avoid it as best as possible. I really don't like the table method on this one because if I use -b over 2a, I get -3, so that's +3 over 2. So my axis of symmetry is 3 over 2. The x component of my vertex is 3 over 2. That means I have to plug 3 over 2 into my equation to get the y component out. I don't like it. But sometimes if you look at it long enough, you might recognize going, oh, wait a minute. This factored to this. It factored to that. Now, this was going through the process of our factoring. Of course, our magic number is 2. You figure which numbers add up to be the -3, and then you find that -2 and -1 work. But if I do this, then this is going to say, hey, you know what? This is going to yield me the point 2, 0. This is going to yield me the point 1, 0. Now, they're right next to each other. What is right in between 1 and 2? 1.5, which is 1.5, right? So my vertex is at 1.5, and that's still the same thing as 3 over 2, and it still kind of sucks. But pattern graphing wouldn't have worked real well on this one if you wouldn't use -b over 2a. Okay? So if I take that -1.5, plug it in there. 1.5 quantity squared. That's 1.5 times 1.5 is 2.25. Okay? And then -3 times 1.5 is -4.5 plus 2. So if I go 2.25 minus 4.5, I get -2.25. -2.25 added to 2 is -0.25. So here is a good luck your vertex. That's what this looks like. The only thing I know for sure is where it crosses the y-axis. So that's a pretty cruddy problem. But it does exist. And those kind of problems, I'd actually say, let's start using our technology to make it work for us. You don't need your noggin to work.
Are those going to be on the test?
Yours, yes, all of them. They're going to be like nasty fractions, like 11/17 and stuff like that. But everyone else gets nice, whole numbers. Is that okay for you to do that, Tim Joe?
Yeah, it's going to be key to design system.
What?
Yeah.
Oh, man.
Yo, cheat on that, bro.
Hey, quit being like the French and looking for people to bail you out. Come on, you know. All right. Hey, second problem. Second problem. What form is that in?
The vertex.
The vertex form. So my vertex on this is going to be 3, -7, right? Opposite value inside because it's grouped, same value outside. So 3. Pattern graphing going to work on this one? 1, 3, 5? No, what's going to be? 2, 6, 10? All right, right one up 2, left one up 2, right one up 6, left one up 6. Hey, look at that, I just found some roots. Hey, does pattern graphing always find your roots? No. Not always. So, what about number 3 up here?
Is that where you do like x plus 3?
Yeah, so this means x is going to happen at 3, so I get 3 comma 0, 1, 2, 3, and x is equal to 1 because it said it equaled 0, so 1 comma 0. And what happens halfway in between 1 and 3?
Your vertex.
My vertex, so 2 happens right there. So if I take 2 and plug it in, remember I have a negative outside, so I have a negative, and then 2 minus 3, that's negative 1, 2 minus 1. So negative times negative is positive, 1 times 1 is 1, 2 comma 1. Yay, look at us. We're so happy. That's it. So there's a lot of different opportunities these work really well. There's a lot of times you have these skills to go through and say, you know, I can start solving this a little bit easier using this way than that way. I can certainly go through and teach you how to complete the square and put them always into vertex form, but it's a longer process. And it deals with the F word, fractions.
Oh,
I know, watch my fraction language. Jeez. Ay, ay, ay. All right, so that last page, this one right here, I would say I would use the negative b over 2a and plug in. Okay, I'd probably do the negative b over 2a on this one as well. Those are the only two I would probably do that one on. This one is set up in, and this one, they're both set up already nice and neat for us to graph them because they're in vertex form. And then these last two, well, this one, you already know what the x-intercepts are, so the roots. This one, you know your vertex has to exist at 0, negative 5. Okay, so there's a whole lot of different opportunities for you to walk through these. Okay, when your b value is 0, there's no reason to say, well, let's keep plugging in negative b over 2a, because that means if your b value is 0, your vertex is always going to happen at 0 comma something. And let's face it, plugging 0 in is pretty easy. Okay, so questions, comments, ideas? What I would like to do, and I thank you all for your patience. You guys did great. So I had assigned this. So tomorrow, which is Thursday, I'm going to check off page 95 and 96. This would have been what I assigned y'all last night. Okay, but we didn't have time really to go through it. I will check that tomorrow. And then I will also be checking off page 97 and 98. That's the new stuff. So both of those pages will be checked off and collected for tomorrow.
This is 95, 96.
No. Look on the bottom, there's not a page number on it.
Alright, Dave, I'll catch you.
I think did we already turn in 95, 96?
95, 96 is what I would have done last night. I signed last night.
We should drill. I go to this class where he's